Alright, so hopefully while you guys were waiting for video 2 to load, you guys tried out example number 2 here. And so let's just jump right into it. So part A here says to determine h of x, and h of x is f of x, divide that by g of x. So we're taking that f of x function, dividing it by g of x. So h of x is equal to, our f of x function was x minus 3 over our g of x, which was x squared minus 8x plus 15. Alright, so if you want to, we could leave it as this, but if we're going to apply what we did last unit or chapter, what we can do is let's simplify this. Let's see if we can cancel out any terms, or if we can change this into maybe a nicer looking function. So first of all, let's start by factoring our denominator. So we have x minus 3 divided by, and here our product is 15 and our sum is negative 8. So what two numbers will multiply to give you positive 15 but add together to be negative 8? And if you guys thought about those answers there, that'd be negative 5 and negative 3. So we're going to rewrite that middle term there. So we have x squared minus 5x minus 3x plus 15. Then we can take out that common factor from each of those groups. So we'll group the first two terms together. There we have x minus 3 over, take out common factor of x. So we have x times x minus 5. Here in the second group we have common factor, we'll pull out that negative 3 so we can have our leftover brackets there to look the same. Then we'll have negative 3 and x minus 5. Grouping together again, we'll pull out that common factor of x minus 5, so we have x minus 3 over x minus 5 times x minus 3. So now we fully, this is fully simplified up to, or I guess fully factored. So now what we can do is, let's look for any things in common and we can start canceling some things out. So if you notice in the numerator and our denominator, we both have x minus 3, so those will cancel out. So that means here that h of x is equal to 1 over x minus 5. And just as one little note there, just remember when we cancel things out, what does that create? So there we have a point of discontinuity. Did you guys remember that? Hey, looking into last chapter. And if you remember what you cancel out, when you set that equal to 0, that value there is your whole. So we have x minus 3. So that means there's a point of discontinuity at x is equal to 3. So be x minus 3 is equal to 0, and then x is equal to 3. And then if we're going to keep going along the same lines of, I guess, our non-permissible values, let's talk about our, we still have a denominator here with a variable in it, so that means that we're going to have a asymptote. Alright, so then you set your denominator equal to 0, so that means that we're going to have, so our x value is there, so that'd be a vertical asymptote. And so set your denominator equal to 0, so it'd be x, move 5 on over, so vertical asymptote at x is equal to 5. Alright. And this is going to be important because in part B we are going to graph this function. It's going to be awesome. Alright, so let's scroll on down there and we're going to move on to part B. So we're going to be graphing all three of these functions. It's going to be awesome. Alright, so let's start off with, we'll do f of x. And that one there was equal to, so f of x was equal to x minus 3. So we'll create our table values from there. And up to this point, if you guys are feeling pretty confident with graphing, you guys are more than welcome to use your graphing calculators. Although I do encourage you, this is our only graphing example, so you know, I definitely encourage you, let's do this all by hand to make sure that we have graphing down pat. Alright, so then for f of x, we're going to set some values, and we can go maybe more along the lines of, we'll go 1, 2, 3, 4, and we'll do a few more. That way we can do our little trick with our h of x function. So we'll do 5 and 6. So I do that just so that we can see those x and y values for when we apply that to the h of x, rather than having to put it into that function. It's going to create a bit of a chaos there. But it'll save us a little bit of time there, unless if you guys would prefer to graph 1 over x I believe that was 1 over x minus 5, which that one there is actually pretty easy to deal with. It talks about what we did just last chapter, so if you guys want to, we can even go ahead and graph, well, we can make a table of values and go from there. Okay? So you guys can choose either option. We'll give you exact same values. So you guys can choose. I'm going to use our little math hack, if I can call it that. So let's get going on with our table of values here. So we have f of x, and when we put x is equal to 1, we have 1 minus 3, which is negative 2. When x is equal to 2, that'd be 2 minus 3, so that'd be negative 1. We have 3. 3 minus 3 is equal to 0. We have 4. 4 minus 3 is equal to 1. If it follows it on in that pattern, we should have 2 and 3 there. Then we'll do graph of g of x. And g of x there was equal to, that was x squared minus 8x plus 15. So create our table values there. So I might create a bit of a bigger one there. And maybe we could choose more along the same points. We should make sure that we try and get our even our x-intercepts in there and our vertex there. So if you guys remember, we did factor this one out before, and it was of course to figure out h of x, but we can still apply that the same factoring to this question. So if you guys remember, that was at 3 and 5. So that is when your function is equal to 0. I'm just going to borrow that work that we did above. And so we should fill in the blanks from there. So we should do at least one in between, one above, one below. Just make sure we got some things going here. We'll go 1 and 2 just to double check. So now let's start plugging in some values for x there. So let's start with x is equal to 1 here. So 1 squared is 1. Negative 8 times 1, so it'll be negative 8, and plus 15. That is equal to, so 1 minus 8 is negative 7, plus 15, so that means y there is equal to 8. When we substitute 2 in for x, we have 2 squared, which is 4. Negative 8 times 2 is negative 16, plus 15 is equal to, so if you guys want to, we can even start here, so negative 15 plus, or negative 16 plus 15, that'll be negative 1 plus 4, that will be positive 3 there. 3 and 5 we already know to be 0, so let's move on over to x is equal to 4. So there we have 4 squared, which is 16. Negative 8 times 4 is negative 32, so subtract 32. Plus 15 is equal to, and depending on how you guys want to do this, 16 minus 32 is negative 16. Plus 15 is negative 1. Then we'll move on to x is equal to 6. That'll be x squared, or 6 squared, which is 36. Subtract 8 times 6 is 48. Plus 15, and that is equal to, so 36 subtract 48, that is negative 12. Plus 15, there is equal to 3. And it should follow that pattern. It is a parabola, so what we notice here is 4, here's our vertex. And it follows that kind of pattern where they keep following that same pattern. So on the outside should be 0, 0, then it'll be 3 and 3. And if we went up to 7, it should, in theory, follow that same pattern, so it should be 8. Okay? But hopefully that's enough there to graph. And so I'm going to quickly do a little graph there for h of x. And I'm going to apologize, I'm out of room. Hopefully you guys should have some room. I was able to do it on my actual piece of paper, but because I have monster writing when I'm doing these lessons, I really don't have some room, so I'm just going to write this just below here. So here we have h of x, and we'll create a table of values for that one there. So we'll do x and y, and I'm going to do, obviously I'll have to do either 1 or 2 more. So our first one there, let's look at when x is equal to 1. I'm just going to use our math hacks and just divide our y values there. So here we have negative 2, divide that by 8, so it'd be negative 2 over 8, or that is also equal to negative 1/4, or as I like to deal with decimals, so that is equal to negative 0.25. When x is equal to 2, y is equal to negative 1, divide that by 3, so that is negative 1/3, which is equal to negative 0.33. We'll create another table of values here. So we have x and y. And so when x is equal to 3, we have 0. Divide that by 0. And if you guys remember at 3 or at point 3, that's where we had our point of discontinuity, or that's where we had our hole. And if we wanted to find out a coordinate for that, we can just plug that into our previous equation there. We had y is equal to 1 over x minus 5. So if we want to do a coordinate for that hole, we'd be at 1 over 3 minus 5, or that'd be negative 1/2. Alright, so if we want to do a coordinate there, then we can do x is equal to 4. So here we're at 1. Divide that by negative 1, so that is just negative 1. And, I'm running out of room once again. I'm just going to write one more right over here. Sorry for this, it might be a little bit confusing with all my table values everywhere, but me and my monster writing gets me into trouble. And so for x here, we just have 2 more points. We have 5 and 6. So 5 is 2, divide that by 0. That is undefined. And that, if you guys remember, that is our asymptote there. And then for x is equal to 6, we have 3, divide that by 3, which is just 1. Alright. So from here we can start graphing everything. So our values range from, it goes from about 1 to 6 for our x values, and our highest point there is 8 for our y values. So maybe every 2 tick marks can be through, or every second tick mark will be 2. Alright, so I'm going to do f of x here. I'm going to do this one here in red. So there we have 1. When x is equal to 1, we're at negative 2. When x is equal to 2, we're at negative 1. When x is equal to 3, we're at 0. When x is equal to 4, we're at 1. And when x is equal to 5, we're at 2. And when x is equal to 6, we're at 3 there. Alright. So it should create a nice straight line there. You guys can please use your rulers. I'm going to switch over to, I'm going to use my clip art here if we don't scribble everywhere. And connect yours with a nice straight line. Alright, let's see if we can make this work here. Alright. Somewhere maybe along those lines there. Let's see if we can even change that color. Oh, or not. Alright, let's see if we can change this to red. Aha, perfect. Alright, so this here is, let's make sure we label this as f of x. And remember, I don't want you to write the whole thing, or else it's going to start being a really cramped graph. But, so there we'll just label it f of x. And I'm going to switch color. We're going to do g of x in a different color. We're going to do g of x here. We're going to do this one here in blue. So when y is equal to, or x is equal to 1, we're at x is equal to 8. And when x is equal to 2, we're at 3. When 3 is equal to, or when x is equal to 3, y is 0. When x is 4, y is at negative 1. When x is 5, we're at 0. And when x is 6, we're at 3 there. Alright. And so we'll connect it. We'll do a nice perfect parabola with me and my shaky hands. It's going to look oh so wonderful. And then we'll label that g of x there. And for our last one there, we're going to pull out, I'm going to use a different color there. And so for h of x there, I'm going to plot first our non-permissible values there. So when x is equal to 3, we have a hole. That is at 1/2. When x is equal to 5, we have a asymptote there. And so actually what I'm going to do here is we're getting close to our 15-minute mark, so please try this rest of this graph out, and we'll go over it in the next video.